I built Minecraft from scratch. No libraries, no imports, all in one file. And the best part is, it runs entirely inside of the terminal. The terminal can only output 2D characters, so how do you make something 3D out of that? The short answer is, we take a 3D world, flatten it into 2D, and use tricks like coloring to make it seem real. That means we need two things: a way to represent the 3D world in code, and a way to turn that representation into an image. But how do you take something so complicated, like a 3D Minecraft world, and represent it in code? Well, we use a 3D array, a grid with an X, Y, and Z coordinate. It starts filled with empty space characters, then we mark solid blocks with something like a 2. This array is just data though, it doesn't look like anything yet. We tell our script to interpret these 2s as solid blocks, and voila! We have our interpretation of the 3D world. Now don't get fooled by this visualization, our job is not done, because this is just a 3D world that sits inside of the computer. The program still has no idea how to take this 3D world and turn it into a 2D image. That's where the renderer comes in. An image is a grid of pixels. For us, a pixel is just a colored character, so our image is really a 2D array of characters printed to the terminal every frame. Great, now we know how we display images to the terminal. But how do we render those images in the first place? The answer is ray tracing. For every pixel on screen, we shoot a ray into the world. The direction of the ray comes from the viewing plane, an imaginary window in front of the player. Whatever it hits determines the pixel's color. On a more technical note, the viewing plane is actually a giant array of vectors, with the player's position and rotation defining the view direction for each pixel. Put together, this gives us a flat-looking world. Hard to tell it's 3D. So how do we make our 3D game 3D? Well, one easy way to fake perspective is to use grid lines. We can add grid lines by coloring rays differently if they hit a point close to the edge of a block. Adding WASD movement and IJKL camera rotation helps more. Pressing those keys move and rotate the player, which automatically moves the viewing plane, helping us convince our minds that we're actually looking at a 3D world. After movement, the logical next step is placing and mining blocks. We fetch the block being looked at by ray tracing from the center of the screen. Then we set that array index to space for mining a block, or 2 if we're placing a block down. Great, now we can mine and place blocks. But everything is still a little too flat for me. How do we get some variation in our terrain? Well, to make a proper terrain generator, we have to use something called Perlin noise. This is because if we used random heights, the terrain would look too uneven. Using Perlin noise gives us a smoother terrain. To understand Perlin noise, picture a grid where every intersection has a random arrow. To sample a point, we find its grid cell, measure the distance to each of the 4 corners, and take the dot product of each distance vector with that corner's arrow. Then, we blend the 4 results based on how close the point is to that corner. Sampling this noise per column gives smooth, natural-looking terrain heights. Now, if you look very closely at the image, you might notice that after all that we've done, everything is still a bland gray with no textures. Is this all we can do? Is this the end of our journey? Is our game doomed to this grayscale hell? Nah, not really. To get textures, we have to use UV mapping. UV mapping tells us which part of a texture image to show on each pixel. When a ray hits a block, we determine which face the ray hit. Top, bottom, side, etc. And then we compute UV coordinates, which go from 0 to 1, based on where on that face the ray landed. Then we sample the right texture using these coordinates. Now we've got color working. But our world still feels a little barren. What could we do? Well, to generate trees, we pick random surface points and run a function that fills in bark and then leaves. For water, any surface point below a certain level that's empty gets filled with a water character. And that puts us in a pretty good spot. In the future, I do want to add stuff in like cave generation, entities, and more, but I think that's enough for today.